I'm Professor Rad, and this is Precalc video 3.3, determining trigonometric values using trig definitions. So in this video, that's what we're going to be doing. We're going to find different trig values using the definitions in terms of x, y, and r for different trig functions. So let's just jump right into this example. So we're going to suppose that cosine of theta is 3/5, and we're told that theta is in the fourth quadrant. And we want to find secant of phi, or we're told secant of phi is -3. And we're told that phi is between these two degree measurements. And we want to find sine and cotangent. So if we're going to be using the trig definitions for this, we're going to need to find the values for x, y, and r so that we can apply the definition. So let's focus first on the one that's got theta, and then we'll do the one that has phi afterwards. So for sine of theta, we know that cosine of theta is 3/5. So we know that the ratio for cosine is the same as x over r. So we can use 3/5 to help us find a value for x and for r by defining x to be 3 and r to be 5. Now, if you wanted to, you could also say that x was 3/5 and r is 1, because 3/5 over 1 gives you 3/5. But if you have it in fraction form, it's nice to use that ratio relationship that we have for our definition. So now that we have x and r, we can use x squared plus y squared equals r squared to help us figure out the value for y. So we have x squared plus y squared is equal to r squared. So 3 squared plus y squared is 5 squared. So we have 9 plus y squared is 25. So that means y squared has to be 16. And be very, very careful here. This is like common mistake alert. Y is plus or minus 4. So we have to make sure that we're including this plus or minus here when we're solving for y. This is because y could be either a positive or a negative value. If we were solving for r, we know it's going to be positive. But when we're solving for x or for y, we could get either a positive or a negative. So to figure out which one we want, that's why they told us that theta was in the fourth quadrant. So I always like to draw a little side picture here. And we're living in the fourth quadrant. So that means I have a positive x value and a negative y value. So that means we're going to want the -4. So I'm going to summarize over here. We said that x is 3, y is -4, and r is 5. So now, just by using the fact that cosine theta was 3/5, we're able to figure out any trig function that we need. So in this case, we want to find sine of theta. So sine of theta is y over r. So sine of theta is y over r. So that means that we have -4 over 5. Da-da-da-da-da-da. There we go. All right, so let's try out finding cotangent of phi if we know secant of phi. And because knowing the quadrant we lived in was important, let's actually sketch out where phi is going to land first. So 180 degrees is going to land us on the negative x-axis, and 270 degrees would land us on the negative y-axis. So phi is going to be in between those two. So that means we have a negative x value and a negative y value. So I know that x is going to be a negative, y is going to be a negative, and r is always positive because r represents the radius of the circle we're using. Okay, so now that we have that down, we know that secant of phi is -3. Now it's helpful to write this in terms of a ratio so that I can find my x, y, and r values more easily. So I'm going to write that as a negative 3/1. So secant, by my definitions, is r over x. So because we have a negative fraction here, r is always positive. So that negative is going to go with the x value. So that means my x value will be -1, and my r value will be 3. So this is r, which is always positive. So that means this negative sign has to get matched with the x. Now we can find our value for y using x squared plus y squared is r squared. So same thing as before. X squared plus y squared is r squared. So I have -1 squared plus y squared is 3 squared. Remember, when you're squaring a negative, you get a positive. So we have 1 plus y squared is 9. Y squared is 8. And so y is plus or minus the square root of 8. Now the square root of 8 has a perfect square factor of 4. So we can simplify that to be 2√2. Sorry for my squeaky marker. And because it is negative, we're going to have the negative square root. So we have negative 2√2. All right, so that's how we find our values for x, y, and r. Now we just have to find cotangent of phi. So cotangent can be found by using x over y. So that's what we're going to do. We're going to take our x value over our y value. So we have cotangent of phi is going to be -1 over -2√2. Now we have to simplify this. So first I notice both top and bottom are negative, so I'm going to be able to get rid of that negative sign. And to rationalize the denominator, I'm going to multiply top and bottom by √2. So this will give me a positive √2 up top. And in the bottom, I have this 2. And √2 times √2 is 2. So we're going to end up getting a positive √2 over 4. So that's our cotangent of phi. And you can do this really for any trig value, right? So if I needed to know, for example, sine of phi, well, I know that sine is y over r. So I would have -2√2 over 3. So once you find x, y, and r, you found the keys to solving these problems. So that's going to be it for this video. Just a couple of examples of applying our trig definitions to find these trig values. In the next video, we're actually going to be doing exactly the same examples, but instead of using the trig definitions, we're going to be using trig properties. So you can see an alternate way to work through these problems and ultimately develop a technique that's going to work best for you. So I look forward to seeing you in that video. In the meantime, I hope you have a magnificent day, and yeah, bye for now.